So next up we have Hardide. We've got Phil Kirkham and Peter Davenport. With the market cap just shy of 40 million, Hardide develops, manufactures and applies advanced technology coatings to a wide range of engineering components. It's a patented technology. It's unique in terms of its toughness and resistance to abrasion and corrosion, together with the ability to coat accurately interior surfaces and complex geometries. This all leads to cost savings, and unsurprisingly they've been able to win a number of blue chip customers across leading companies, including operating in the oil and gas, both exploration and production, valve and pump manufacturing, precision engineering, and also, especially more recently, the aerospace sector. Recent interim results suggested very much that H1 has set the group well on track to meet market expectations for the full year. And we've got Phil Kirkham and Peter Davenport here this evening. Phil was appointed CEO in September 2012. Before joining Hardide, he was CEO of private equity-backed Material Advantage Group, which supplies machined metal components to the oil and gas industry mainly. He's a chartered engineer and previously held senior management positions at Rolls-Royce. Peter joined in 2005, was appointed finance director in March 2006. A BA from Oxford University, he trained as an accountant within Royal Mail and worked for Parcel Force Worldwide before joining the UK subsidiary of global coatings company Valspar. So it's a pleasure to introduce you this evening, the CEO of Hardide, Phil Kirkham.
Thank you. Thank you. Thank you, and good evening. So, Hardide. Hardide is a unique family of coatings. It's an engineered coating, it's a very hard-wearing coating and patented technology. And the history of Hardide is very interesting. It came out of a fundamental research project at Moscow University in the Soviet era. And when the wall came down and perestroika happened and the universities were bereft of funding, a number of people got some commercial entities together to look at transferring technology outside the Soviet Union. And in 1999, this technology came out of the Soviet Union. An investor in the Oxford area saw it and brought one of the founders over, who's still with us, our technical director, Dr. Yuri Zhuk, brought him over to the UK and started the technology literally in an office. So from that, we've grown into premises in Bicester near Oxford, and the company went public in 2005 on the AIM market. So we're a patented coating. It was developed and commercialised in the UK. It's what's called CVD, which is chemical vapour deposition, which I'll explain a little bit later on. And it has a unique combination of properties of hardness, toughness, abrasion resistance, corrosion resistance. And it essentially does what other coatings cannot do, and that is uniformly coat internal surfaces in very complex shapes. Most other coatings that apply hard-wearing tungsten carbide coatings like we do are what we call line of sight. So you can only coat the parts you can actually physically see. And these coatings are generally sprayed on by some sort of gun or line of sight process. The Hardide process is a gas phase process. It's done in a reactor. You can see two reactors there. The vacuum reactors, the components go inside the reactor, heated up to about 500 centigrade. A mixture of gases then enters that reactor, and a chemical reaction takes place between the gases on the surface of the component itself, and the coating is created and crystallised atom by atom on the component. So it completely uniformly covers whatever part of the component that we want to coat. So the business model is that we provide coating services to other businesses. So customers send their parts to us from all over the world. We coat them and send them back. Our main site is in Bicester in the UK, and that's where we've been since 2003. In 2016, we opened another coating facility in Virginia in the States, because we have a lot of business. Approximately 50% of our turnover comes out of North America. So this is obviously why we opened a facility over there. Our customers, we supply all the major oil and gas service providers around the world, and other blue chip companies like General Electric, Airbus, BAE Systems, Leonardo Helicopters, EDF Energy, And I really wish I could put a slide up like my previous colleague did, showing a whole variety of customer names. We are not allowed to. We are very restricted by non-disclosure and confidentiality agreements with our customers who just do not want to publicise the advantages our coating gives them in their products. As I say, we're listed on AIM 2005, and we're currently investing for growth of the business. We recently did a fundraising last October. We got 2.5 million raised, oversubscribed, and that is for investment in Virginia predominantly. We got money to put 2 further coating reactors into Virginia, but also increase our business development resource and do operational enhancements in the Bicester facility. So we have 2 main facilities, the UK head office and the main coating facility where we do all our main R&D, and the site in Virginia, 25,000 square foot facility in Virginia. And we also have the original laboratory in Moscow where the fundamental research was done. We still have scientists there with all that previous experience who work with us on looking at future patentable applications or patentable forms of the coating. And as I will explain, Hardide is a family of coating. It's a range of coating. It's a spectrum. So just to put some key facts on one page, our turnover this year, the market forecast is around 4 million. With a head count of 40 people, roughly 30 in the UK and 10 in the States at the moment. So it's a patented technologies. We have 5 families of patents that cover the technology, and we'll show you that a little bit more later on. Our main office and coating facility is in Bicester, and with the US facility opened in 2016. Our current major markets, and roughly 2/3 of our turnover comes out of the oil and gas market at the moment, and that is directional drilling, completion tooling, and hydraulic fracturing. Those are the main areas that we currently supply in the oil industry. But interestingly, the developing markets are aerospace and power generation. These are very exciting large markets for us. And particularly on the aerospace, we've been working since 2008 with Airbus developing a variant of the coating to replace hard chrome plating, which is effectively banned under the European REACH regulations. So our margins are high. With a high variable margin in the 70%, and gross margins sort of mid-50s. Very high operational gearing, so we don't have to put a lot of extra cost in if we want to increase our volume and our capacity. We're very close to break even now, as you'll see from Peter later on with some of the numbers. And over the past 2 years in particular, our sales growth has been more than 30% year on year. And again, we'll show you those figures. The balance sheet is very strong now. We've got a good cash on the balance sheet as a result of the fundraising. And two particular approvals we have. BAE Systems approval. We've been supplying components on the Eurofighter Typhoon since 2005, and we still are. And more recently, we have achieved full Airbus approval for supplying flying parts for the Airbus programs. We're currently in the final stages of approval with Leonardo Helicopters, the old Augusta Westland down in Yeovil, and the product in test there at the moment. So as I say, it's a patented technology. The coating is crystallised literally atom by atom, from this chemical vapor deposition process. It deposits on the coating, it's created on the surface of the component, very good adhesion, and can coat very, very complex shapes. As I say, it does what other coatings cannot do. It uniformly coats these complex shapes internally and externally, and these non-line of sight areas. And as you can see on some of the examples here, we've got a pelletizer die plate with hundreds of small holes in, maybe 2-3 millimeter diameter. We can coat inside those holes. Ball valves, the exterior of a ball valve, internal cylinders, a number of components here from the oil industry, and a later development is turbine blades. So why do we do it? Well, the coating lasts a lot longer. Typically here 250 times greater wear resistance than steel, uncoated steel. Because of the way the coating deposits and crystallises uniformly, there are no voids in the coating, so no aggressive chemicals can get through the coating to the substrate. Hence it has an excellent corrosion resistance. And because of its nanostructure, in creating the toughness and the wear resistance, coated parts last many times longer in service, and this gives the customers the benefit. So normally we will coat a relatively small component from a larger tool or machine, and that component is traditionally the one that wears out first, that determines the life of the machine. So by coating that component, we can make the whole system last longer, and that's where we score, and that's where we give our customers major benefits. But we also, because we can coat the complex shapes and the internal surfaces that other coatings cannot do, we can give engineers the opportunity to design things differently and use cheaper substrate materials, and then put the hardide coating on, saving them cost. So we're a real differentiator. It's a real disruptive technology. So as I say at the outset, it's a family of coatings. It's not just one coating. And we can produce any coatings from a soft coating, which is basically pure tungsten, up to a very hard coating, which is essentially tungsten carbide, and anything in between. But the vast majority of what we do is Hardide T, which we developed originally for the oil industry, and that's 95% of what we do currently is Hardide T, which has, you know, excellent toughness and wear resistance and is designed to be harder than sand. Sand is the main wear and factor within oil industry that causes wear and damage to products. But more recently, as I said, we've been developing with Airbus a variant, and this is the variant Hardide A, which has got properties and dimensional properties and hardness similar to hard chrome. So it becomes a direct replacement on the component for hard chrome. The engineers don't have to redesign and go through the stress calculations again for the product. They can just apply hardide instead of hard chrome. So this has had a great take up. It's taken 8-9 years in development with Airbus. The coating was approved a couple of 18 months ago. The plant has now been approved by Airbus, so we're now in the final stages of testing actual components, flying components, before we hopefully get into significant revenue. We have 5 families of patents, 2 protect the composition structure and the deposition of the coating itself, and within that there is a chemical composition fingerprint. So if we ever found that anybody was trying to, or we thought anybody was trying to do something to compete within a similar technology, we can actually analyse their coating, and if we find this fingerprint, and if it matches what the fingerprint that we have patented, then obviously we can challenge that. But so far we've never seen anybody try to do anything like what we're doing. We also have 2 patents for coating of diamonds. These are not diamonds on your ring. These are industrial diamonds used in very hard, aggressive wear conditions, particularly in the oil industry. And a patent for self-sharpening blades. So it's like a never-ending sharpening blade. That we're trademarked in the UK, in the EU and the US. And we're continually looking at new applications for coating. We're looking at new patentable potentials, and this is what some of the guys in Moscow are currently working on. Our key markets are oil and gas is the main market. As I said earlier, we're used by all the leading oil and gas service providers, mainly downhole, hydraulic fracturing, subsea applications. You can see drilling tools on this slide there. Flow control is pumps and valves, again for severe service environments, highly corrosive environments. Precision engineering is really the catch-all that doesn't fit anywhere else. So it's power generation, it's plastics extrusion. We saw some dies earlier on. There's a new generation of X-ray baggage screening machine that incorporates our coated product. It's a very high-speed machine. It's 3 times faster than any conventional baggage screening machine for airports. We worked with this company for over 10 years while they were developing their machine. It went into production last year, so now we're integral into that machine and integral to how it actually operates, and getting regular revenue and growing revenue from that customer. Aerospace is the big market that we expect to see in the coming years, particularly with Airbus and Leonardo helicopters, but this is giving us spin-offs into many other global aerospace players at the moment. So on Airbus, on the fixed wing side, we're fully approved to supply flying components. It's a direct replacement for hard chrome plating, and hard chrome plating is used extensively within aircraft, or has been used extensively within aircraft. And we are currently in discussions with Airbus and testing with Airbus on parts for both the A320, the A330, A350 and the A380 aircraft. Of course, the A320 is the prize, because that's the high volume single aisle, where Airbus are currently up in the production rate up to 60 or 63 aircraft per month. BAE Systems, as I mentioned, we've been coating parts on the Typhoon since 2005, and we continue to do so. Leonardo, on the helicopter side, we have components in testing on the rotor head, very critical, safety critical components, as you can imagine, on the rotor head, and in the transmission system on the gearbox structure. And there's tests actually ongoing as we speak on that, and we're hopeful that will come to a full approval situation very shortly. And obviously, with the Airbus approval has given us the entry into many other global aerospace companies, particularly people who make actuators for landing gear and the wing and flap structures. And we've got many trials and many discussions going on with a whole variety of component suppliers at the moment throughout Europe and throughout North America, and where there's significant volumes on these components. We're fully accredited. We have the Aerospace Quality Management System AS 9100 Revision D, the latest revision. We also have NADCAP approval for our coatings process, and NADCAP is the global aerospace approval process run by the primes. It's run by the Boeings and Airbus and Leonardos to approve the actual production process of coating. So we're fully approved from them now. And ISO 9001 and the environmental standard 14001 as well. So we just, as Gareth said, we just released our interims last month. So this is just a slide out of there. So our sales revenue increased 43% compared with the same period in 2017, and 25% higher compared with the second half of 2017. So again, good growth in the business, particularly from our oil and gas sector, which was up 54% in that period. But both flow control and precision engineering sectors were also ahead of the same period in 2017. In our year-end statement last year, we announced two new supply agreements. The first of those started in the first half, towards the end of the first half, and the second of those has just started in the second half of this year, this last month. So these are two major supply agreements, both in the oil and gas industry, one with a global operator and the other with a tool manufacturer. So both of these are very significant for us. With Airbus, we've got multiple components in trial at the moment, and as I mentioned, Leonardo, we've got transmission components currently in test. US aerospace is a big market, and we are regularly talking to and visiting customers in the US aerospace sector, and we believe that will develop very strongly for us as well. The Virginia facility was opened in January 2016, and we've just completed all the work necessary to get that facility approved to aerospace standard AS 9100 as well, and we hope to be able to announce that accreditation very, very shortly now. As I mentioned, we had a fundraising back in October, funding for growth. We ordered a new reactor for Martinsville facility. There's currently 2 reactors in Martinsville. We've got a 3rd on order, which will be delivered this August, September, to cater for the projected growth in the North American markets that we see there. So I've got some financial trend information. I'll just pass over to Peter now, who will just take you through these numbers.
I'll be quite quick, I promise. But this is basically the last 5 half years, so two full financial years. So you can see really the trend in sales revenue. So these numbers here are against the previous half, but over the 2 years, sales have more than doubled. Now, I will admit it's slightly flattering because that half there was really the bottom of the oil and gas market, where obviously when prices are down at $30 a barrel, nobody's drilling, therefore nobody really has any equipment to coat. So that was the low point of our oil and gas revenues. But we've been, like I said, we've doubled in the 2 years since then. Gross profit is up by an even greater degree because our costs, although sales are up 43%, the cost of sales are only up 21%. So obviously the margin is then increases by an even greater degree. Now, the only fly in the ointment is here, where we've got a slight flattening in gross margins. As Phil said, our normal modus operandi is people send us their components, we coat them and send them back. But what we've now started doing for a couple of customers is we provide the coated component to them. So basically we're simplifying their supply chain by we source the component, add the coating and give them a coated component. So obviously that hits the margin because we have an increased cost of sales. We have to actually subcontract the manufacture of the component in there. And EBITDA has gone from a 0.7 loss to in the first half of this year to a loss of 0.14. I think Phil's really been through all this, the fundraising. The overheads did increase. These are against the first half of last year. We received some very good grants from Virginia for locating our facility there, and those have started to tail off. And there were also some adverse currency movements and some recruitment costs as well as we increased our technical team, our R&D effort. CapEx in the first half of this year was 360 grand. Most of that was due to the down payment costs for the reactor that we've ordered, which is going into Virginia in the second half of the year. The income statement, again, there's not really an awful lot to point out. Other than there, you see the flattening of the variable margin as more of our sales start incorporating a manufactured component, not just the coating component. And the balance sheet, of those assets in the top, only 70k is purchased goodwill. The rest of those assets are all things that you can kick and touch and feel. It's all fixed assets, plant and machinery and stuff like that. So there's no intangibles on the balance sheet other than a little bit of purchased goodwill. The other thing to point out is the effect of on working capital of that increase in sales. So sales went up by 650k from the first half of last year, but we've only got just over 100k impact on working capital in there as well. So the impact, it doesn't really strain the balance sheet to increase sales by quite a degree. And the cash flow, again, the operating cash flow really mirrors the EBITDA. Again, there's little impact on cash flow from the increase in sales. A lot of it basically flows through into cash very quickly. We got the proceeds of the share issue there. We have taken on a small loan from the Virginia Economic Development people. They wanted to contribute towards the investment that we're making in the Virginia facility. So it's basically a flat rate 2% interest. So it was quite hard to say no to that, and that's repayable over 5 years. So that's pretty much it from a financial point of view.
Happy to answer any questions you have.
On a simplistic level, can you say how much annual revenue a new reactor can generate? Is there a read across?
Yeah, we use a rule of thumb that a reactor will generate around £1 million worth of revenue on average, on an average mix and average selling price.
You've got you will have the 3 reactors in the US. How many in total do you have?
We've currently got 3 in the UK. So I'll have, come September, October, I will have 6. 3 in the UK, 3 in the US. But in the US, we have a very large facility, which is only less than 50% utilised in terms of space, and we deliberately did that to give us plenty of room for expansion for the future. So we could easily get 6 or 7 reactors into the Martinsville facility in Virginia. That's exactly why we did it. In the UK, we are constrained on space. We can't get any more reactors into our current facility because of the way we've developed from a small business and we've just grown. So at the moment we're physically constrained in terms of space in the UK. So we would have to look for more premises to install. If we wanted to install more reactors in the UK, which hopefully we'll do as business grows, we'll have to look for more premises.
My question's associated. What is the lifespan of those reactors at Bicester, and how much is the replacement cost?
Okay, if I can say that the first one of those reactors was bought just when I arrived in 2005, and it's still going strong. They don't have many moving parts, so there's not an awful lot to wear out on them.
Basically, the parts that do wear out are maintainable. You know what I mean? Like, we've got pumps to create the vacuum. Well, you just refurbish the pump. So it's not as though there's pieces of kit on there that aren't just don't just form part of the normal maintenance routine that we maintain. So I'm not saying they've got an indefinite life, but there's no sign of any issues or wear on this one that's 12, 13 years old. So they've got a long life.
Could I ask a couple of questions about, you mentioned the fundraise back in October a few times. What price was that done at?
1.7p.
And can you say which institutions came in then and who your major institutional shareholders are?
We've got two family groupings who were both in pre-float, who have both got around 15%, 30% between them roughly. And then we have Hargreave Hale, we've got Amati, VCT Trusts, we've got Unicorn Asset Management.
Quite a lot of the funds actually came from private client brokers, Hargreave Hale in York. We've got a very good relationship with them.
Okay, and the last bit of that, I just wondered, was there an open offer for?
No, it was a placing.
Just an institutional placing. Okay, thank you.
Hi, yeah, just a question about how much is a reactor?
All in, including, I mean, there's various bits and bobs which go around it, but all in, it's about 600,000 euros.
And how occupied are the 3 reactors in the UK? How well utilised are they?
It obviously varies from day to day, month to month, but we don't want to be 100% utilised because I need capacity for development. And because we're a service, we need to be able to offer a short lead time. Therefore, you have to have the capacity to cope with the increases in demand. So we always aim to run at around 75% capacity as a maximum to be able to maintain our service levels. It varies. We're probably running you know, sort of 70% in the UK, lower in the US at the moment because we're building up that
Is
customer
that like
base.
1 shift, 2 shift, 3 shifts, 5 days
No,
a
the
week,
way,
7 days a week?
Yeah,
How is
the
that?
way the system works is it's a vacuum reactor. It's a batch process, and that batch process can take anything from 12 to 24 hours. So we get 1 reactor load coated per day per reactor. So we work on a single day shift. The reactors run overnight on a lights out basis. They're automatically programmed, computer controlled. So during the day we do all the manual work of unloading, getting the next load ready, etc.
So they are operating 70% of all time?
Yeah.
Okay. Okay.
Can I ask two questions? One is, you say that you're used by all the leading oil and gas service companies, but your sales in the oil and gas sector grew by 50% or so last year. So can you just explain where that growth is coming from?
Well,
Yeah.
Sorry.
And then the second question is just, how can you give us some sort of order of magnitude difference between the oil and gas market and the potential in the aerospace market?
The sales grew 54% from last year in oil and gas on the back of a recovery in the oil and gas markets was the predominant feature there. But also we've generated some new opportunities and some new applications during that time as well. So it's not just purely recovery from our old existing customers in terms of their demands increase. There's more drilling rigs now than there was, you know, a year ago active. We've picked up new opportunities as well during that period. And these 2 new supply contracts I talk about now are not really in any figures we've shown you. And that's you know, projected turnover for the future. Oil and gas is always going to be a significant opportunity for us, and we've much further to go still in oil and gas. We've nowhere near saturation point on our coating in oil and gas. Aerospace at the moment is small beer for us. We're hoping that we'll get significant contracts out of Airbus, Leonardo, and others. The market potential for us in aerospace is probably larger than the oil and gas opportunity. Difficult to be precise about it, but certainly, you know, we see it running into the opportunities for us could run into many millions in aerospace. Okay.
Do you need an average oil price for your customers to keep going back?
Well, I think our customers need an average oil price to keep drilling. Yeah. I mean, we saw a big downturn when it got down to $28 a barrel. Yeah, our customers, you know, significantly reduced their demand, which obviously affected us. And we've seen that recovery as it's gone back up to $70, $75.
When did you start to see that recovery taking place?
Probably about 9 months ago, as the oil price started to rise, as the production cuts, you know, started taking effect from OPEC. But of course, we're into the fracking tools as well, which we traditionally haven't been. The oil price that the frackers need is a lot lower than what the land base, in particular the subsea, the offshore drillers need. So the recovery in the fracking market, it happens much quicker than the recovery in any other land-based drilling, or particularly subsea. I mean, subsea still has not yet recovered. We've not seen any recovery in our subsea business, so that is still to come as well. We're just starting to see signs of it, and our customers are reporting that they are starting to see some activity increase in offshore. So that's still to come through.
Okay. And you know, when you said about your 95% oil at the moment, was that
75?
Oh, was it 75?
75.
So sort of 75.
Well, 70.
70-30 sort of split between oil and the rest of your activities. But aerospace, you're saying, I'm not sure, the expected value of that market could run into millions. Have you any idea of the addressable size of the market?
It's very difficult to pin what the market is. There's a replacement for hard chrome, which is our initial market opportunity, which is what we're talking to Airbus and Leonardo about. But more recently, we've seen people wanting to replace another coating, which is called HVOF, tungsten carbide sprayed coating. They're now talking about replacing that with Hardide as well, which just opens up the opportunities even further for us. So I'm not trying to be evasive, but it's just so difficult. It's such a huge market opportunity for us, and we're just talking to, you know, a relatively small part of the market at the moment. It is a massive opportunity for us to capture long term, but it will take time. I mean, aerospace takes time to develop, as we've seen 8-9 years with Airbus to get where we've got to now.
Yeah, that was going to be my final question.
Which is a huge barrier to entry for everybody else.
Yeah, that was my final question in terms of the time from you start to the time of approval. Obviously, if you do get approval, so because I followed you for quite a while, and the Airbus, it's taken quite a while, hasn't it? Are there different lead times from trial to approval, depending on who you're with?
Within aerospace or in different industries?
Just generally, is
yes, there is. I think probably the quickest we've done is probably 9 months to a year from inception, from first contact to actual coating. Typically, 18 months to 2 years is fairly typical as a good average, particularly within the oil industry. By the time they've assessed the coating, done some initial laboratory trials, coated some components, put it down hole, tested it, seen how it's performed, it's at least 18 months to 2 years is a good typical average, yeah.
I've got a couple of questions about the patent family that you just mentioned. Do these patents cover the mode of delivery of the coating? You know, you mentioned gas and heat in a reactor, or does it control the actual material that's being applied, or both?
Yes, it's as it says here, it predicts the composition, the structure, and how it's deposited. That's really the main patents that we have that are protected.
And then the process that you've gone through so far with Airbus, once they qualify you for a component, do you have to go through the same process for each new component they might use, or are you in with...
Not each component. There's components run into families of components, as you can imagine. So once we're approved for a family, within that generic family, we will be approved. It won't have to be every single component needs a lifetime test. But if it's a completely different type of component with completely different loads and stresses on it, then it might need a separate test program. But that's a relatively short test program in the sense of what we've been doing at the moment.
And last question from me: if you were to get a sudden breakthrough with Airbus, say, and can you see a situation where they'd be reluctant to give you a large contract because you wouldn't have the capacity to fulfill it? Is that a barrier to your getting a breakthrough? It's
not a barrier to us getting a breakthrough. It's something we'd have to consider in terms of the ramp up of any production orders we got from Airbus. This could well prompt us to look at extra premises to invest more capacity in a separate site, because as I say, we can't get more than the 3 reactors that we currently have at Bicester because we're full in terms of space. But yes, it's definitely a consideration that we'd have to make sure we have sufficient capacity to cope with the extra volume we're getting. Yeah, absolutely. But it'd be a nice problem to have.
Thank you.
So thank you very much to Phil and Peter from Hardide.